inequalities. Inequalities arise when, instead of equations, for example, 2x equals 4, we have a relationship that is not actually an equality, but a relationship nonetheless. This sort of thing might arise when I say I can have no more than 12 students in a classroom, or the class can't run unless there are 5 or more students involved. So there's a lot of situations which are best represented by an inequality. X is greater than 5, x is equal to or less than 4, rather than an equality. We can solve inequations with the same process as which we solve equations, and it's often useful to plot the result on a number line. We have to be able to distinguish between greater than and greater than or equal to, and the way we would plot our various inequalities, you draw a number line. Now this is just showing A, just for the purpose of having a general visual. Your number line would have to show at least the number that we're relating x to and a few numbers on either side. If x is greater than A, we start with our number line, we put a circle above the number line. So x is greater than A, we put a circle above A, and x is greater than A, so x is an infinite number of possible solutions above A. So to represent that, we put a line with an arrow showing that our solutions continue up this way, and because x cannot be equal to A, we leave our circle open to show that x starts just above A. If, however, x was greater than or equal to A, our circle above A would be shaded in to show that x, the solution set of x, does include the value A. So that's how we would graph those on the number line. If x was less than A, our circle is still there, it's open because it can't be A, but x is this set of solutions less than A. Less than or equal to A, we would simply colour it in. We can also get inequalities where we are given a relationship of x to two different numbers. Sometimes it can be x is either less than A or more than B. So we actually have two circles and arrows heading off this way. Here x is greater than A, but x is less than or equal to B. So when you see this, you know that x is between A and B. Moving up there, sorry. And this one would start with a circle at A. It's an open circle because it can't be equal to A. The circle at B will be a closed circle because x can equal B. And then we'll represent our solution set of x like so. So the type of question you're likely to get is solve the following and graph the solutions on a number line. There are two extra little tricks that we may need to take into account. We'll start with this. Honestly, when you're solving it, pretend this is an equal sign. If I had 3x plus 4 equals 13, I know exactly how I'd solve it. I'd subtract 4 from both sides first, so 3x is greater than 13 minus 4 is 9. If I had 3x equals 9, great, I'd just divide by 3. So x, 9 divided by 3 is 3. X is greater than 3. So it works exactly the same way as if there was an equal sign there. We're just solving it and always putting the inequality in instead of the equal sign. When we're then asked to graph the solution on a number line, please use a ruler, preferably not with a fountain pen that's going to make a mess like mine just did. Please make sure your gradations are even, arrows on either end. Make sure you've got enough digits that you're showing a few numbers either side of the number that we're going to be graphing. Put your circle over 3. Do not colour it in because x can't equal 3. X is greater than 3, so we're going this way. We have solved and graphed the solution. Now, here we've got a demonstration of one of the tricky little aspects of an inequation, which is that I'll have a negative x. So I'm subtracting 4 from both sides to get rid of this 4. So I've got negative x on 3 is less than or equal to 2. Now, in order to get x on its own, I will be multiplying by negative 3, because this negative can belong to the x or the 3, so I might as well deal with just let's multiply by negative 3 and get x on its own. Now, if you are multiplying or dividing by a negative, there is one aspect that has to be taken into account. So, multiplying or dividing by a negative, you must change the direction of the sign. Now, if you don't see why, it's a good idea just to set up a tiny little inequality that's true. Negative 2 is less than 4. This is true. Negative 2 less than 4. Absolutely, definitely. If we multiplied both sides by a negative, and we'll choose negative 1, so I've got negative 2 times negative 1, and I've got 4 times negative 1. Have a look at what happens. Negative 2 times negative 1 is 2. 4 times negative 1 is negative 4. 2 is definitely not less than negative 4. So, when you multiply both sides by a negative, you are reversing the relationship between them, and you must reverse the sign. So here, where I'm multiplying both sides by negative 3, I'll be left with x. 2 times negative 3 is negative 6, and you must reverse the sign. X is greater than or equal to negative 6. Plot this on a number line. Even gradations. Choose a set of numbers where you've got a few numbers either side. Closed circle over negative 6, and x is greater than, so our line is going up this way. Now for this one, I'm just going to ignore one of my normal rules. Normally, of course, I would choose to move the 3x. If you always prefer to move the pronumeral from the right-hand side, so you're left with the pronumeral on the left-hand side, which is very sensible. If I subtracted 6x from both sides here, I'd be left with negative 3x plus 2 is greater than negative 4. What have I done wrong there? Sorry. This is obviously a perfectly correct solution. I was just meant to set this up so that I demonstrate one other problem. And of course I'm going to do this the way I would normally do it, which is I would be taking away 3x from both sides, because I always take away the one with the smallest coefficient in absolute terms. So 2 is greater than or equal to, take away 3x from both sides, I've got 3x minus 4. And this would be useful. I'd obviously do this because I wouldn't end up with a nasty negative x. Sorry about that. So getting rid of my -4, add 4 to both sides. I've got 6 is greater than 3x. I'm going to divide both sides by 3. 2 is greater than x. And again, I've been left with the x on the right-hand side, and I want to have the x on the left-hand side. Again, here is a situation where you must reverse the direction of the sign, because if 2 is greater than x, then when I turn it around, I'm reading x is less than 2. So just doing this that particular way to show you that if I'm switching the sides around, I do have to switch the sign around as well. So the last reminder, switching sides, switch the sign. And of course we'd graph that. I made that a bit big. Circle above the 2, it's an open circle, and x is, oops, less than. And this is one of the reasons it's always a good idea to have more numbers than you need around your value, because I was thinking I was going greater than, realized my mistake, and I still had some numbers to spare down there. So that is inequalities.